Hey, Mr. Chan.
Hi, Mr. Drowse.
So, I know we learned a lot about the arithmetic sequences, but what are we going to be learning in this video tutorial?
We're going to be talking about geometric sequences, specifically how to write explicit equations for a geometric sequence and its applications.
Nice. Can't wait.
Here we have a sequence of 4 terms. The first term is positive 128, falls to negative 64, 32, negative 16. And this is unlike the kinds of sequences that we've done in the past, specifically arithmetic sequences, that we remember increase or decrease by addition or subtraction. In this case, the common difference is plus 2, right? 2 to 4 to 6 to 8. This new sequence is different from that. It's not, they're not progressing by addition or subtraction. That's pretty obvious. So let's determine how the sequence is progressing. And we're going to refer to the each change from the first term to the next as the common ratio. So how are we going to do that? We're going to be using this formula right here. So we're going to determine the common ratio by a sub n divided by a sub n minus 1. So basically, you're going to be selecting a term and then dividing it by the previous term, the one right before it or to the left. So when we're looking at the sequence, we see that we've got, again, 128 to negative 64 to 32. If we take negative 64, and this will be a sub n, and divide it by the previous term, that's going to give us negative 1/2. If we selected another two numbers along the sequence, let's say that we selected the last two terms, and we had negative 16 divided by 32. That's also going to give us the same ratio, negative 1/2. That's really critical as we're moving forward using something called the geometric sequence equation. So this is the explicit equation we're going to be using throughout this tutorial. This is the moneymaker. You might want to pause and jot this down. It's critical that you know this. So now that we know the ratio, how are we going to apply this explicit equation to find, for example, the 11th term? So we have the first 4 terms. Well, we know the ratio, which is negative 1/2. And if we plug in this information, we'll be able to figure out what the 11th term is. So let's do that right now. So if we're looking for the 11th term, we're going to pop that in right here. So instead of a sub n, we're going to do a sub n, a sub 11 equals the first term. So I see it says a sub 1. We know that in this sequence, I can see that 128 is the first term, so we can pop that in. Multiplied by the ratio, negative 1/2, and we're raising this to the power of 10, which we know is n minus 1, and in this case, n is going to be 11. 11 minus 1 is 10. And when we do that, we're going to need to make sure that we raise both the numerator and the denominator to 10 separately. So this is going to be negative 1 raised to the 10th power. This is positive 2 raised to the 10th power. When you do the math using your handy-dandy calculator, you're going to figure out that this is going to be equal to positive 1. 1 times 128 is going to give us 128. 2 to the power of 10 is going to give us 1024. When simplified, is going to give us 1/8. And 1/8 is the 11th term in this sequence. So how is the geometric sequence different from an arithmetic sequence, which we remember is the addition or subtraction of a constant difference from one term to the next? Well, geometric sequence is where each term after the first one is found by multiplying the previous one by a fixed non-zero number called the common ratio. So here we have 1 to 4 to 16 to 64. What is that going to look like in practice, and how do we apply the explicit equation formula? Let's take a look. We've got to find that common ratio, which remember we just learned is where you take one term and divide it by the previous term. In this case, 4 divided by 1, it's going to give us 4. Alternatively, we could have taken, 64 and divided it by 16. So that gives us the common ratio. In this case, again, 4. We're going to be plugging that in to the explicit equation formula. And let's say for this equation, we're going to be looking for a sub 9. How do we find the 9th term? Well, we're going to change a sub n to a sub 9 multiplied by the first term, which remember in this case is 1, right? So 1 times the ratio, which we just figured out is 4, raised to the 8th power because n minus 1, if n is 9, n minus 1 is 8, And now we're going to need to apply the order of operations. 4 raised to the 8th power is going to give us 65,536, and then you're going to multiply it by 1, which is the same thing. So this is the 9th term. This is our answer. Here we have a sequence of 4 terms. The first term is 3, jumps to 9, 27, and then 81. My question to you guys is, how are we going to find the 11th term? Well, we're going to be using the explicit equation formula to do that. First, we're going to need to find out the ratio. So we know that we're going to take a term, let's say 9, and divide it by the previous term. In this case, it's 3. That's going to give us the ratio. In this case, it's 3. Alternatively, we could have taken 81 and done 81 divided by 27, the previous term, and that would have also given us 3. So we've got the ratio, and we've got our formula, which is a sub n equals the first term times the ratio raised to n minus 1. In this case, it's going to be a sub 11, which is the term that we're looking for, equals to the first term, which is 3, multiplied by the ratio that we just figured out, raised to the 10th power because it's 11 minus 1. And when you plug that into your calculator, that's going to let us know that the 11th term is 177,147. Tremendous. This is our answer. So here we have a sequence that oscillates from negative to positive, and we're going to be looking for the 9th term in this sequence. So that is our objective. How do we find the 9th term? First, we're going to need to figure out what the ratio is, and we know that we're going to take a term and divide it by the previous term. So 40 divided by negative 80 is going to give us negative 1/2. This is our ratio, so we can now move forward and apply that to our explicit equation formula. And we know that if we're looking for the 9th term, we're going to plug in a sub 9 equals the first term. In this case, it's going to be negative 80, right? Multiplied by the ratio, which is negative 1/2, raised to the 8th power. Why 8? Because we're looking for the 9th term, and this is n minus 1. Next, what we need to do is apply order of operations. So we're not really worried about the negative 80 yet. Instead, we're thinking about how to apply this power of 8 to this fraction. We're going to be raising the numerator and the denominator individually to the 8th power. So you're going to want to make sure that you do negative 1 to the 8th and 2 to the 8th. And when you do that, you're going to get, in the calculator, negative 0.3125. And if you do math and then enter, which will give us the fraction, it's going to be negative 5/16. And that is the 9th term in this sequence. This is our answer. Finding the common ratio can be a little bit tricky when there are fractions involved in our sequence. So how do we approach something like this? Well, let's say that we take term b, which is going to be negative 8/3, divided by the previous term, in this case 4. And what will that look like? Well, a fraction by a fraction, in this case, negative 8/3, divided by 4/1, can be done in your calculator, but it might be a little bit easier if instead of division, you're going to be multiplying by the reciprocal. So what is a reciprocal? That is going to be, in this case, the bottom term, positive 4/1, and you're going to be flipping it so the numerator becomes the denominator, and the bottom term becomes the top term. So what does that look like in practice? Well, we're going to be multiplying across now. Negative 8 times 1 is going to give us negative 8, of course. The denominator's 3 times 4 is going to give us positive 12. We're not done yet. We've got to simplify. And when we do, that's going to give us negative 2/3. That is our ratio. And that's what we're going to be using moving forth as we find terms using the explicit equation. Here we have another geometric sequence. The first term is 4, 6, 9, 27/2. We're going to figure out the ratio by dividing 6 divided by 4. That's going to give us 3/2 when simplified. We've got a ratio. We then plug that into our formula. A sub n equals the first term times ratio raised to n minus 1. In this case, we're going to be looking for the 9th term. So it's going to be a sub 9 equals the first term. times the ratio, 3 over 2 raised to the 8th power. We're going to be then raising both the numerator and denominator individually, which gives us 6,561 over 256. When we multiply across, 4 times 6,561, that's going to give us 26,244 over 256, still because 4 is the same as 4 over 1. The denominator is not changing. We can simplify that. When we do, that's going to give us 6,561 over 64. That is our ninth term. What do we do, though, when the only information we're given in a sequence is the fifth term and the ratio, in this case, being -6? How do we operate? Well, the first thing that we need to do is figure out what the first term is. So how do we find a sub 1? That way we can apply the explicit equation. Well, we know that the fifth term is 2,592. And we know that we don't know the first term, but we do know the ratio. So if the ratio is -6, what we're going to do is we're going to simply plug that in right here. And we can now operate on the second stage of this problem. We can swap out the fifth term for 2,592. We know that because that information is given in the very beginning, equals a sub 1 times the ratio, -6, raised to the 4th power, right, 5 minus 1. Now what do? We need to get the first term by itself, so we're going to divide out 1,296, which is the ratio raised to the 4th power. And when we divide that out from both sides, that's going to give us 2. So the first term in this problem is 2. We're not out of the woods yet. Now what we need to do is take that first term and plug it into the explicit equation. And we've now got our answer. So we've got a sub n equals 2 times the ratio raised to n minus 1. So now we can figure out what the value is of any term in this sequence. Let's try this again. So let's say that we're only given the fifth term, which is -36. And let's say we are only given the ratio, which is, again is -6. How do we figure out what the first term is in this sequence? Well, what we're going to do is we know that a sub 5 equals a sub 1 times r raised to 5 minus 1. We can swap out a sub 5 for -36 because that's given in the very beginning of the problem. And we can also swap out r for -6 because that, again, is given information. We're going to raise that to the 4th power. And when we do a little multiplication, we know that -6 raised to the 4th power is 1296. And 1,296 divided by itself cancels out. And so the first term, when we divide this on both sides, the first term is now -1 over 36. We've got our first term. We can then apply that to the explicit equation formula. And this is our answer. Again, how do we find the explicit equation? If we're given the third term, which in this case is -135, and the ratio, which is -1 over 3, how do we proceed? Well, here we've got our formula, and we're going to swap out a sub n for a sub 3 equals a sub 1. That's what we're looking for, times the ratio, which we know is -1/3, over raised to 3 minus 1. Well, what we can then do is, as we're moving forth, we can change a sub 3 to -135. We know that because that's the given information. And when we raise our ratio, -1/3, to the power of 2, that's going to give us 1 over 9. We can then how do we get a sub 1 by itself? This might be a little bit tricky. So instead of dividing both sides by 1/9, instead what we can do is multiply by the reciprocal. When we're looking at the right side, we know that 1 times 9 is 9, and 9 times 1 is 9. 9 over 9 is 1. So these cancel out. Bam, 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 bam. All we're left with on the right side is a sub 1. And on the left side, we're going to multiply by 9 over 1. In this case, we're going to be multiplying 9 times -135. And that's going to give us -1,215 over 1. And that is our first term. So now we've got the explicit equation for geometric sequence this is our answer right here. How do we find the explicit equation if we're given the fifth term in the sequence, which is 12, and the ratio, which is 2? We're going to be using our formula. We're going to be making a sub n, a sub 5 equals a sub 1, which is what we need to figure out, right? Multiplied by the ratio raised to 5 over 1. We can swap out a sub 5 for 12. We know that because that information is given in the beginning, equals a sub 1 times the ratio raised to 4. And 2 raised to the 4 is 16. We then divide both sides by 16. So these, of course, cancel out. A sub 1 equals 12 over 16, which reduces to positive 3 over 4. We then take that first term, we plug it into our explicit equation, and this is our answer. Let's do this one more time. So let's say we're given the sixth term and the ratio. So if the sixth term in this sequence is 32, the ratio is negative 1/2. What we do is, using this formula, we're going to plug in a sub 6 equals a sub 1, which we need to get by itself, multiplied by the ratio, raised to 6 minus 1, because this is the sixth term, and this is n minus 1, right? We are then going to change a sub 6 to 32, because that information is given and we need the value, equals a sub 1. We're going to now raise this to the fifth power, and raising both the numerator, negative 1, and the denominator, 2, to the fifth power. And when we do that, that's going to give us negative 1 over 32, right, when you use your calculators. And now we need to get a sub 1 by itself. So how do we do that? We're going to be multiplying both sides by the reciprocal. And I see that the negative 1's cancel out right there. The 32's cancel out. And on the left side, we're going to be multiplying negative 32 times positive 32. And 1 times 1, and what does that give us? That's going to give us negative 1,224, I'm sorry, negative 1,024. That is our first term. We're going to take that, plug that into our equation, and this is our answer. How do we figure out what subsequent terms are in a sequence if we don't know the ratio, and the only thing that we do know is the first term, which in this case is negative 2, and the third term, in this case, is negative 50. What are the steps? How do we figure out what that ratio is? So let's jump right in. We don't know the second term, but we do know what the explicit equation formula is. So we can start plugging information in. So let's say instead of a sub n, we're going to be using a sub 3, which we know is negative 50. So we can write a sub 3 equals negative 2. Why negative 2? Well, that's the first term. Now we don't need to figure out what the first term is because that's given. We don't know what the ratio is, but we are going to raise it to the power of 2 because n minus 1 is 2. 3 minus 1, of course, is 2. Now what we're going to do is to isolate r. What we're going to do is we're going to divide both sides by negative 2, and the 2's, of course, cancel out, and negative 50 divided by 2 is positive 25. So negative 25 equals r squared. How do we get r by itself? What we're going to do is apply the square root to both sides, and when we square root both sides, we're left with simply the ratio equaling either positive or negative 5. So we're almost done. We're 99% there. We're going to be having actually two formulas, two equations to give us subsequent terms. We're going to be applying a sub n equals the first term, which we know is negative 2, times the ratio, which we just figured out, and we know it's both positive and negative, raised to n minus 1. So this is our answer. What do we do if we know the first term, in this case negative 3, and the third term, in this case negative 75, but we don't know what the common ratio is? Well, we're going to be using the explicit equation formula to our advantage by popping in this information. So let's say that instead of a sub n, we're going to be doing a sub 3, which we know is negative 75. So let's pop in negative 75 equals the first term, which we know is negative 3, times the ratio, which we don't know, raised to 2, because 3 minus 1 is 2, and we're working with the third term. So let's do a little bit of math. We need to get ultimately the ratio by itself. So let's get rid of this first term. We're going to divide both sides by -3. The -3's cancel out. And we're doing that because -3 is being multiplied by the ratio. That's what this operation is right here. We've got to do the inverse. So we're doing, of course, division. -75 divided by -3 is going to give us positive 25. 25 equals ratio squared. How do we get rid of this 2 right there? It's raised to the second power. Well, what we're going to do is apply square root to both sides. And when we square root both sides, this disappears. So we're left with just the ratio. Square root of 25 is positive or -5. So we're going to have two equations as a result. So what is our answer? Our explicit equation for this geometric sequence is going to be a sub n equals -3, which is the same for both equations because it's the first term. That doesn't change, but the ratio does. So it's either positive 5 or -5 raised to n minus 1, n minus 1. For a little bit of review, here we have the equation for the recursive arithmetic sequence, which we know is a sub n equals a sub n minus 1 plus the difference. And a sub 1, of course, equals k. So what does that look like in practice? Well, let's say the first term is positive 3, right? So that's going to be this right here, a sub 1 equals, instead of k, it's going to be 3. And here we've got the difference, which is -4. So what is the second term? So the second term is the first term, and the difference plus the difference, which is -4, giving us -1. So -1 is the second term. What's the third term? The third term is a sub n minus 1, the previous term, which we know is -1, plus the difference, which is -4, giving us -5. The fourth term is the previous term, -5, plus the difference, which is -4, giving us -1. And the fifth term is the previous term plus the difference, giving us -13. So what does a geometric recursive sequence look like? Well, here is that formula. And instead of the addition of the difference, we're going to be multiplying by the ratio. Otherwise, it's pretty similar. What does this application look like? So let's say we've got the first term, and in this case, it's going to be -2, and the ratio is positive 3. Well, to figure out what a sub 2 is, we're going to be taking the previous term, and the previous term is a sub 1, which is -2, multiplied by the ratio, which is 3, giving us -6. What is a sub 3? What is the third term in the sequence? Well, that's going to be the second term, which is a sub n minus 1, right? Multiplied by the ratio, giving us -18. The fourth term is the previous term, right? A sub n minus 1, multiplied by the ratio, giving us -54. So a sub 4 is -54. And a sub 5 is the previous term, a sub n minus 1, multiplied by the ratio, giving us -162. Again, we have the formula for the recursive equation for a geometric sequence. We've got the first term, which is -3, the ratio, which is 2. So what would the second term be? The second term is going to be the previous term, which is the first term, multiplied by the ratio, giving us -6. The third term is the previous term, so this is a sub 2 right here, right? This is a sub 2 times the ratio, giving us -12. So a sub 3 is -12. The fourth term is the third term multiplied by the ratio, giving us -24. And the fifth term is the previous term, -24, multiplied by the ratio, giving us -48. To review the last video tutorial, and to wrap this one up, let's take a look at this sequence, it's arithmetic, and determine what the explicit equation is and the recursive equation. To do that, we're going to need to figure out what the difference is, and we know to determine the difference, we're going to take one term and subtract it by the previous term. So in this case, 5 minus 2 is going to give us 3. That's our difference. We can then plug that into our explicit equation formula, right? So it's going to be a sub n equals -4, which is the first term, plus the difference, that we just figured out, times n minus 1. So that's the explicit equation. What is the recursive? We're going to do a sub n equals the previous term plus the difference. And the first term, of course, is -4. What's that going to look like for a geometric sequence? So here we have our geometric sequence, which we know does not increase or decrease by addition or subtraction. It's increasing or decreasing by multiplication. In this case, by the multiplication of a fraction, which is 1/2. We know that to determine the ratio, we're going to take one term and divide it by the previous term. So 16 divided by 32 is going to give us 1/2, or 4 divided by 8 is going to give us 1/2. We've got that ratio. How do we plug that ratio in to get the explicit equation? It's going to be a sub n equals 32, which is the first term, right, times the ratio, which we just figured out, raised to n minus 1. What is the recursive? The recursive is a sub n equals the previous term, a sub n minus 1, multiplied by the ratio, and the first term is going to be 32.
Well, I hope that was helpful for you guys, but Mr. Chan, I have a question.
What's that?
What should kids do if they still feel a little confused?
Well, a couple of things you can do. You can certainly watch this video over again. There's always, of course, office hours,
That's
which
great.
is between 8 to 8:30. Also during lunch. So
You'll help out kids during lunch?
yeah, absolutely.
You're the best, Mr. Chan.
No, you're the best.